Welcome to my YouTube channel Codes Nest. Hope you are enjoying these videos in Scratch. If you have still not subscribed to my channel, I request you to please subscribe to it. So we have covered so many important concepts in so many projects. So today we are going to learn very special concept called 3D raycasting. So how we create that 3D raycasting? We paint backdrops. Then we create custom blocks like raycasters. So from 2D we create 3D impression by using these raycasters. Especially we will be using pen extension. So this will be create impression of 3D from 2D. So we will use multiple light beams. So these are I hope you are going to enjoy it. So let's start this 3D raycasting project. Choose a backdrop and here we will choose paint a backdrop option. So here, so we'll choose this backdrop and in this backdrop we'll choose a color. First of all we'll convert it to bitmap. Then we'll go to fill. In fill we will choose a color black. So black, what we will do? So we'll change the brightness to 0 and then we'll choose, maybe we can choose 100 also, there's no issue, it should be black color. So we'll just click it and this is black. Okay, so our this is complete. So first this one we will delete it. Now after backdrop is complete, now we'll go to this sprite. So in sprite section we'll draw paint a sprite. So in paint a sprite again we have gone to costume section. In costume section, while painting a sprite, so what sprite we want to paint, right? So we want to basically paint a sprite which will be our like a mystery room of our this 3D recasting plan. So let's draw this maze. In this maze we'll try to use a color as a gray. So how we can use that? So just change the brightness and color also. So this color we maybe saturation is 0 and brightness we can say 50 or say 60. Okay, so color can be 0. So this brightness. Now what we'll do next? We'll now select the rectangle. By using rectangle, first of all we have to cover all the boundary walls. So by covering all the boundary walls, why this is very important, later on if we leave any gap in between, so this will create difficulty in our recasting. So we'll first cover all the boundary walls. So we'll not use any outline. So outline we will remove it. So by reducing it. So adjust it. Now we'll go for others. Similarly we'll start for this. Similarly we'll go for this. Adjust, so we can adjust if we want, and this also we can adjust if we want. This is a little less, so we can increase it. Similarly from here. So our boundary is complete. So there is no gap. So ray cannot cross between any gap on it. So okay. So now we'll try to create our scene. So here we will create little rooms. So I will create that. We'll again use the same tool of rectangle. So we'll select rectangle and draw some rooms. So whichever it suits you, you can use that. So this room, mystery rooms, basically it's like a mystery room. You can create some fun here. Here also you can create like this. So these basically, it appears like we are going into a maze. Okay, so we want to create some circular block. We can create that also. Okay, so here also if we want to say go for rectangle, so we can create that. So that is done. So if you want to create anything else, that we will also be able to do. For the time being, now our this 3D maze as well as this using gray, we have created a sprite. So this, why we are using simple gray rectangles, we learn because these basically work well with the flat walls. So what we ensure that we drive full wall across entire design. Then we have not left this any gaps. Then we have making, now we have started making corridors. Hope you enjoyed making these walls and all that. So now what we want is that we want this whole design to be in center. So how we can do that? We'll just go to the code, and when the green flag is clicked, so what we should do, we write just go to xy00, go to xy00. So we'll drag this block and type here xy00. Okay, so that is done. So if we just green flag is clicked, so see this stage is now centered. Okay, so now this is done. Before that, we will name this as a sprite as our design. So now we'll go for next, paint a sprite. In this paint a sprite, what we are going to draw a player. So for that purpose, we will just enlarge it. So we can see there blocks are visible. We are able to see these blocks. So they are very clearly, distinctively visible now. So we'll choose a color. Say we will choose a color yellow. Increase the brightness to 100 and saturation to 100. So now all colors are visible. So we'll choose the color yellow. Okay. So in yellow, so then now we'll again choose this rectangle, and we'll choose this perfect this yellow part. Now to convert scale into triangle, what we will do, we'll just go to select this reshaping tool, and then on one of these corners we will just click it 2 times. Okay, so this reshaping tool, so this snaps. So see, it has snapped. So now we'll drag it in a, what we want to drag it, so we'll just make it a center. We'll use the select tool. Using select tools, want to make it center, and further we want it to face this direction. So we'll drag it further to make it look little better. So we'll drag it like this, and here we can see that, okay, so it is touching these 2 points. Okay, so we may reduce it if we want. Okay, we want just this side, this is also possible. So this is our player now. See that center, okay, I clicked it, so it is matching. So our player is now created. This player will be one who will be walking through our maze. So we have named it, we have to name it as a player. Right, here in costume also we'll name it as a player. Right, so this we have created a player also. So what we are going to do next? So we will be doing coding of the player. Go to the code, and code what we are going to want to start. We again want our player should be comfortably situated at center. So let's go like when the green flag is clicked, and go to the motion, go to the X, 0, 0. So let's click the green flag. So see this on this stage our player is at center position comfortably. So now further we want that it should face 45 direction, 545 degree upwards. So for that purpose we'll just we will add a block that 45 degree it should move. So what is the, can you tell? So we have a block point in direction 45. So this is point in direction, we'll drag this and we'll mention point in direction 45. And further we want that our costume should always be like this one only. What is the costume we just have created? So by chance, so we'll create others costume also. So for this purpose we'll go to looks, and so what will we count, that will switch this costume to player. So we have now done it, this player sprite. So what play now, so this player will be moving through whole this maze. So first we are going to create in a 2D level, then we will shift to 3D effects. So for what we want from our player, so how we can achieve this? So you are free to achieve anyway. So we have to use raycasting later on. So we can use forever loop. Then in forever loop we will use the if loops, multiple if loops. Okay. So further what we can do, we can just use this press key commands. On that way, if you will check if the whether which arrow keys are pressed, right key arrow key pressed, left arrow key pressed, right? So we'll then accordingly move plus or minus. Okay, so if we write code, so what code will it be like? So we will first create a forever loop. In forever loop we will check for this left arrow, right arrow, up arrow and down arrow, and if left arrow is pressed, then what will it will be basically turning towards left, say for example 3 degree. Similarly it will move 3 degree right, we press right arrow, and up for up arrow we'll just move 2 steps, and for down arrow we'll simply move 2 steps. Okay, so from 2 steps minus. So what we will do now next, so basically what we are going to create is a forever loop and these all if commands in it. Okay, so let's go, we'll go first of all we'll create a forever loop. Okay, so in forever loop we'll just enter if commands, if this then. Okay, so first if then loop will be our first if left arrow key is pressed. So where is the key pressed? So we'll go to event when the it is written when this, so we'll go to basically this is key pressing. So this is, I think this is a different, so we will go to this will go to sensing commands. So in sensing commands, this key space is pressed. So we'll drag it, and here we'll, in space key, we'll just for up arrow, or what we can say we can say left arrow. Okay, when left arrow is pressed, what we want, we should turn to 3° left. Okay, so we'll go to motion, and we want turn 3° left. Okay, so we want, similarly we want to duplicate it. Okay, so this is for right arrow, when this is left and right. So right, we want, instead of turn 3° this left, we want it should turn 3° right. So it is 3° right. So okay, so similarly what we want that for this should be there should be commands for up arrow and down arrow. So if we, this first of all, we'll select up arrow. If up arrow is pressed, then this will drag out and snap it, and it should move 2 forward steps. Similarly, we will select from here, when down arrow is pressed, then it should move, we'll snap it and get move command. So we'll move, say, -2 steps. Okay, so as you can see, this little code is now, we have made it functional. So so what we want, shall we test it? Okay, so let's test it. So when green flag is clicked, so these are arrows. Okay, so see, this is left and right. So we are going to now, left arrows are moving, so we will go to again test it. If key is up, key is move 2 steps. So see what is problem, why it's not moving. So we have put all the in further loop, so this all if block should be separate. So now let's test it again. So see, it is moving forward, this is moving reverse, it's left and right angle, so it's moving. So we are okay. So what is the problem here, can we tell? Yes, what is the problem, that it will move through the walls. It is not interesting. So we have created this design also, we have created player also. So to avoid player to wall collision, we have to create a code, a script. So in this script, we want that just as soon as this player walks forward or backward through these walls, so he should be pushed away from it. So to handle this situation, we can use a custom block. In my blocks, we can create a my block. So we will name this block as a move, and further we'll run it without screen refresh and add an text input. This number, what we'll write here, steps. Okay, so because we are going to replace the steps part, so this move steps is here. Okay, so further, wherever it is move 2 steps, so what we are going to create, so we are going to replace these move 2 steps with our custom move blocks. So we'll snap it out, and in their place we'll just drag this move block. Okay, so what here we will write, this will be move 2 and it will move -2. Okay, so we have done, and we'll snap these move blocks. In their place we have now custom move blocks. So now what does it move means, move to? So we are now will define it. So how we'll define it? We will basically, what we want, the custom block will replace this forward and backward movement. So, and this way further, this move defining should detect the collision. So if we, how we can define that, if this movement, this touches this design, the design is this sprite created. So when it touches it, then it should move away from this boundary. So, or it can move backwards 2 steps. So steps we have already defined. So how we can create? Just here, first select motion and move, we'll just drag it, and here from here we'll, instead of 10, we'll just move steps. Okay, so this we have defined it, move steps, and then now we'll place a control loop. What will be control loop? That if our one condition, what is that condition? That if it touches, so touches where is sensing command, but it touches design. Design is our stage. So when it is touching our design, okay, then what should happen? It should move. So where is motion? So we'll again go move these steps, and here we want to move it backwards from 0. So we'll just use this minus logical operator, and here move we will say write 0, and whatever steps are there we'll write 0 minus steps, it will move backwards. So right, so shall we test it now? Okay, let's test it. So is it, see, let's okay, now see, it is not able to walk through the walls. Okay, so it is, so our purpose, it's moving forward, backwards, right? So that is good, and it's not moving towards the wall. Okay, see, now our movements are stopped. We are either, this code has detected collision, it's now not working at all. So this collision we want to avoid, so we'll use a concept of hitbox. We'll create a second, we'll just stop this script, and just we'll go to player. In player we will create, go to the costumes. In costume we'll create another costume and name this costume as hitbox. Okay, so hitbox, we'll see, we are able to see these small pixels, right? So what we're going to do in pixels, we have to just clear, okay, go to bitmap. Okay, so in bitmap we are going to use this rectangle, and color we have already chosen yellow color, and now we'll just use one complete, it's, if we're not complete, just drag it, that one full 4 by 4 pixel is filled, right? When it is done, just drag it on it, place it on center, so it is now in center. So our hitbox is created. So if hitbox is created, now what is our next option? So we have to go to back to our code. So we have to update our code. So in this, how we'll update? We'll go update our define our moves script. Okay, so we'll go to the code, and there is a define moves script. So it's moving so many steps. Now we'll just see, we are able to see this now hitbox here. This hitbox, see why it was getting struck. First of all, we have to learn this science, because it is a triangle, and one side when it is fixed here and it rotates, it gets collision. So we will, instead of to just avoid that problem, we will use this one pixel, this one 4 by 4 pixel, this small square, so that this problem does not come. And further we will avoid this problem. Why? We will always keep this non-rotating part. So if it is non-rotating, it will not touch the wall and collide. So how we will achieve that? We will first of all, we will add here block that go to the looks and switch costume to the hitbox. We have just now created, and after creating hitbox, we will just go to rotation style. Okay, so we'll go to motion, and there is a rotation style. Okay, we'll go to set the rotation style. So we will set it to rotation style, do not rotate. Okay, so this is now done. Now after this script, what we want, that it comes back to normal costume of player. So how it can come? We'll again go to the looks and select switch costume to, instead of hitbox, what we will write? Player. Okay, and then again rotation style, go to motion and go to rotation style. So now it should be able to rotate everywhere after this check, right? So this is now done, and now shall we test it? Okay, we'll test it. Okay, so let's see now. Yes, now it is able to move. It is, although it is overlapping, but it's not getting stuck. Why? Because we are choosing hitbox. Hitbox is a small sphere which is not rotating, so it is able to facilitate our movements. Okay, so but still there is issue. What is that issue? Said that this is sticking with the walls, so it is like, right? So we have to improve that also. Okay, movement of this player which is obstructed when it gets struck with wall, we can use trigonometric functions, so like sine and cos. So if, and further, how we can move it? Suppose this sprite, see this sprite, it gets struck. Okay, it gets struck. For example, we run this code. Okay, so this is getting struck here. Okay, for example, this is getting struck. So instead of this is moving, pointing toward this direction. Okay, so if we split this direction into x part and y part, okay, so this means if it cannot move in x part, so it can move definitely in y part. So how we can achieve that? By taking the direction and using this sine function, cosine function. Okay, so we'll try to do that. So before we do that, first we create a try to move block, because we are struck. We'll name it like that. So we'll go to my blocks, make a block, name it as a try move. Okay, so we'll give two inputs, dx, and next add another input, dy. Okay, and further we have to select run without screen refresh, press OK. So this then will move it here, and then what we are going to do here, just like we did earlier, we will move, change x and change y, change x and change y. So how we are going to change it? We are going to change it by dx and dy. Okay, so it will change. Further, what we want to check, that if it is this x and y, both of them will keep a check whether they are touching our design. If they are touching our design, then we'll move it back 0 minus dx and 0 minus dy. So how we'll be able to do that? Go to control block and make a if loop, and if loop will test it, that if it is touching. So we'll use this touching command, and here's touch design. So we'll select this touch design and drag this and put this condition in if loop here, and then we'll change x by, again go to motion and this change x by. Okay, so this is by. Okay, similarly what we'll do, say change y by. What we'll put here, we put a logical operator here, minus operator. Similarly again we'll put here minus operator. Here we'll write 0 minus dx. Similarly here we'll write 0 minus dy. Okay, so now what is complete? Like our try move block is complete. Now how to use this try move block is so that whenever we get struck, our movement still continues. Okay, our try move block is ready. So we should implement here. We'll separate this script in 3 parts. Okay, we separated out this if block. So in if block, what we will do? So in here we will use our new variables. is try move. Okay, so in try move, so this we have defined this try move, and now we are going to use this try move. Okay, so using sin x and cos x functions. So what we'll do here, so we will create a variable here. So what will be variable? We will multiplication logical operator here. So we'll drag it and use this multiple function. So what will be the function here? So we'll further use a multiplication to sine of this direction. Okay, so here we will use, instead of here we will use steps. Okay, so we'll use steps. Okay, steps is there. Now steps should be multiplied by sine of the function. So logical operator is there. So we'll use this sine of the function and drag this here. Okay, so sine of what we want here, we want a direction. Okay, sine of direction. So we'll go to direction. Direction will be in look motion part. This is direction, sine of player direction. Okay, so further what we want, so we want, so this we can snap this if block. Okay, we have snapped it. So now similarly we can duplicate this and place it here. Okay, so now both our x and y, these are complete. So now we have split it into two sine, we have written a cos here. So by when we test it, so it is now not passing through the walls, and moreover it is functioning exactly as it was functioning earlier. Okay, so what we want, see this, when this is so close, so but still that issue, so how it is exactly functioning same way. So what we will do now, we'll add one more try move block. Go to my blocks and use try move block here. Okay, so we'll now drag this cos function and put it here. So it will be in right part. So we'll write the 0, and here will be x will be 0. So now we'll put it back. Let's now test our function, how it works now. See, so yes, it is now gliding. Wonderful. It is now not getting stuck anywhere. Now even we go close, it is moving. See, are you able to see it? See, I am going so close, but now when I move, it is able to move it. This is, I am able to achieve it. That is wonderful thing. Now we are able to use movements by left key, arrow key, then right arrow key, then up arrow key and down arrow key. We should also be able to use this player strafing. What is that called? By using WASD keys. So we will now create that. How we'll be able to do that? Just see, how can we tell that? So what we want to do, we want that our player should be able to strafe. Okay, so for that purpose we'll use this up and down, as well as we'll add two more blocks, if blocks here. So if up arrow key is pressed, or whether we can say that W is pressed, so that should move by two blocks. And similarly, if either down arrow key is pressed or S is pressed, so it should move -2 steps. So how will we achieve that? We will use a logical operator here, or operator here. So we'll drag this in first condition, and second condition again will sense this key press, and here we will, instead of up arrow key, we'll write W. So W, when either W key is pressed or up arrow key, so it will move two steps. Similarly, here also we'll drag an operator or operator. So here also, so we'll drag operator, and then in here we'll write S key pressed. So again go to sensing block and drag this key press, and here instead of space we'll change it to S, is S key. So either S key is pressed or down key is pressed, it will move -2 step. Now we want to add A and D. A for player strafing, we want when we press the A key, it should move to left. Okay, so if it should move to left, then what we want, just and what we'll do, we'll add a if block, further if block here. Okay, so if block will go to this, and we'll add a if block, and in if block we will say sensing if key is pressed. Okay, so first we'll say when A key is pressed. Okay, when A key is pressed, then what should happen, then it should first of all, it should turn left by 90 degree, and because it is a strafing, so we want it should move 2 steps. So how it will move 2 steps, can anybody tell? Yes, so when this is moving, so see, we want that either A key is pressed or D is pressed, so it will be moving by 90 degrees, and then after that we will use this block, my blocks, and use a move command. So here we will write move 2 steps, and similarly we'll duplicate it and use it for D block when we use when D key is pressed. So instead of A is that block, it's not duplicated. Check where is the block. So this is block, so it has changed to there. So where is further it is moving, where this A is pressed. Okay, so now we'll this S key is pressed, then W is pressed, left arrow. Okay, left arrow is pressed and up arrow is pressed. Okay, so it has changed, right? So I think this has gone here, left and right, so it should be, instead of left it should be right arrow. Okay, so it is done. So then it is up arrow. Okay, so if either up arrow is pressed or W is pressed, then down arrow is pressed or S is pressed. Okay, so it will move like this. So now we'll add one more block here, control block if. So here again we will go to sensing, and if here we'll write D key is pressed. When D key is pressed, then again we should move. Now it has turned to left, so we'll also move it to right also. Should move by 90 degree. Similarly here it is right, first it should move to right 90 degree, then it should move. I'll go to my blocks and use my block of 2, and after that I will use turn left. So I will use here 90 degree again. See W S A D. Okay, I have done it. So I will check my code again, script palette. See if everything is fine. Is there any sideways? Okay, it's clean. Here also it is clean. So you want to say that okay. Okay, this all is done. Okay, so our let's now test it. Okay. Okay, let's see how it's working. So we will press the green flag and it's working. Now I am going to press WA key. So see, it's troughing. It's wonderful. So now you press D key. Wonderful. Now W key. Now S key. So this is wonderful. It is done. Our first basic level, place troughing, we are able to complete it. Now move on to slowly towards 3D concepts. So for that purpose, what we will do is we'll duplicate this player sprite and name it as a Raycaster. Okay. So now it's done. So in for Raycaster, we'll delete all this script, whatever it is. So delete all the blocks. Okay. Says okay. We'll delete all these blocks for player costume. So now, now what we are going to do is here we'll go to costumes and also delete this player costume. So we are left only with the hitbox. Okay, so that's done. So now we'll go to code, Raycaster code. So Raycaster code, what we are going to do is go to events. When the green flag is clicked, then switch costumes. So we switch costume to what we'll go do. Go to switch costume to hitbox. This is our present this costume, and then after that, what we are going to do that it should not rotate. Set the rotation style to do not rotate. Okay, so this is done. Now we want to fire this projectile as per this player. Okay, so wherever our player goes, we want that this should our this Raycaster should follow it. So how we can achieve that? So when, for example, to start with, let's say when this space key is pressed. Okay, and the space key is pressed, then what we want, so this Raycaster should point towards the in the direction of player. So we'll write that point in direction. Okay, so instead of 90 we want player or direction. So there is a, so we will go to this, there is a function, so we'll drag it here. So instead of stage we'll go to player, and in next direction we will write direction. So it's a very wonderful function. So we'll point towards the direction of this player. So what else we want? We want that it should repeat until so it touches our design. So this, when this file the projectile, so this ray will act as its Raycaster. So it will test the touching of the walls. So we will again put a repeat loop here. So what we'll do, repeat until use. Okay, so we'll use this repeat loop. So in a repeat until loop, so we'll, what will be the condition when it will be touching the design. So we'll again go to touching the repeat until. So it touching, instead of mouse it will be when it will be touching the design, what we want, it should move 4 steps. So we'll write move 4 steps. Okay, so okay, so let's now test how it works. So design it. So let's now space key is pressed. Okay, so see it's now not in the same position. So it's not got to player. So we have to modify that it should also go to the player. So how we'll go write a command for go to the player? We'll go to the motion. So instead of go to the player, so we'll follow this to go to the player here. So we'll write when space key is also go to the player. So see now what will it change just when we'll press. So when space key is pressed, now see it's working. It's wonderful. So this is our acting as our ray. Okay, so it's falling. Okay, so we are able to fire the projectile using this concept. So this is our perfectly working. Raycaster, this sprite, it gets overlapped with the walls. Okay, so see, so why it is so? So there is a concept that, see, this raycaster, you might be remembering, it is 4 by 4 pixels. So when our distance between this player and this is not is a multiple of this 4 pixels, then it is okay. If it is not, then according to that, this sprite either goes overlapped with the walls or the object head. So how can we take care of it? Okay, so we can say that if it is touching the sprite means this design, then it is moving 4 steps. Okay, but if it is not touching, then it should move -1 steps. Okay, let's try to add this code and see how it works. Okay, so we'll repeat. This is move 4 steps. Okay, we have already done it, so we'll again duplicate it, and instead of touching the design, we will use not operator, and now we'll drag this not touching the design, and here we will put -1. Okay, so let's now test it. Okay, so now yes, see, it is bouncing back. So now this problem is resolved. So now what we are going to do, we're going to change a little bit. So we'll create one block and name it as a single ray. Okay, and for this purpose, what we'll do next, so this will rather a single ray will use a run without refresh. Okay, this block, now how will it define single ray? So single ray will go just this drag all the behind this point in direction to define single ray, and here we'll drag this single ray, will go to player and then move back to raycaster and move this single ray here. Okay, so now this single ray we have placed below point in direction of player, and single ray we have defined as at the right side. So what is single ray? Go to player, repeat these actions. So this will cover our action. So let's see how this works differently. Sure, see, you're able to see it is almost instantaneously. So this is difference. Now as soon as I click this space key, it is fired, the projectile is fired. Little update it. So we'll use a very beautiful extension, very good extension of pen extension. Okay, so by using pen extension, where will you use it? So we will use here, mouse is clicked, so here we will use erase all. Okay, after using erase all, what we will do next? We'll say set pen's color, pen. Okay, so we set pen color by this is okay. So what we will set? We'll say pen color to 50, say 53. So next, what we can say? Pen size also we can set. We can, okay, so it is 1. We can change pen size by 4. Okay, so next what we can do? We can say point is already done. One point is how to use this in our single ray. So we'll go to player is there. So here we'll use pen down. It will start using the pen down function, and at the end we'll use pen up function. Okay, so let's now test what has happened with this pen extension. Press the green key, and after that we'll press, I am going to press space key. Oh, that's great. So I am able to see. Ha! That is wonderful. Wonderful. That is a laser beam. It looks like laser beam. That's great. Instead of this size, because it's increasing, what we can do to reduce this size, we can change from here. Instead of change pen size by 4, we can set pen size to 4. So it will now remain fixed instead of moving. So let's try. Let's run this project again and click it, and now see. So now the size of laser beam remains constant. So it's very wonderful. So I am enjoying. We can keep on. I can keep on doing this. This is wonderful. As we have a laser gun in our hand, right? Pressed. We cannot keep on pressing the space key. Okay. So we'll remove this when the space key is pressed. Okay, this block we will remove it, and instead of this, will when I receive message, and what receive message I receive, when I receive the message of new message, I will write it this message as raycast. Okay. So whenever I will receive this message of raycast, this function will be completed. And where I will now broadcast it, I will go to this player sprite, and player sprite I will broadcast this message. So how will I broadcast this message? Again, go to event and broadcast ray message, and I will place it here. So this will be now in forever loop. You can see that this is forever loop. Forever loop, this will continuously sending this broadcast message, raycast, and this raycaster will continue to receive raycast, and this pen will be able to use. Okay, so this is very good. So this now let's going to test it. See, now it's without my pressing of space key, it is working. This is so wonderful. This is wonderful that I have now automated this laser key. No need to press space key, just by arrow keys and A, S, D, this W. So I can move it, right? So this is wonderful. So I am able to move it. Single ray, we want to have multiple rays, right? So how we want to do that? So we'll do that, but we'll write a code. So we'll what we'll do, instead this we have multi-direction single ray cast. So what we'll do, this instead of single ray, so we'll create a block, name that, make a block, and name of the block we will write raycast. Okay, so again we'll run with it without screen refresh and press OK. So in defining the raycast, what we'll say, we'll add a repeat loop. Okay, in repeat 10 loop, what we also says, this will add a single ray and then turn it by say 5 degree. Okay, turn it by 5 degree. Okay, so turn it by 5. So what else we can do? Okay, so this is, instead of 50 we write 5 degrees. Okay, so now further we'll put this this raycast. Okay, go to this my blocks. So this, drag this raycast, and raycast will add it here. So let's run. See, so beautiful. See, now I have rays instead of this. Okay, so I am going to fire multiple rays. Okay, so now I am able to do it. So this is how I move it. So okay, so this is wonderful. So I am able to do it. That's great. So I have, this looks so beautiful, right? It's wonderful. If we want to increase the number of rays, okay, it's like looking like a concert, right? So if you want to increase the number of rays, what we can do is we can create a variable, new variable, and name the variable as FOV. This is field of view, or you can think it like a spread of rays. Okay, so for all sprites, and do it OK, and then you can set the value of FOV to 60 and place it under the when the green flag is clicked. Okay, so it is now 60, and now we will use this FOV value, this FOV variable, and repeat 10 times. We will replace here under raycast by FOV, because now and further to look it make it more attractive, we'll use slider and use this range. Minimum value will be 30 and maximum value will be 120. So we'll press OK. So now we can change this from 30 to 120. So we'll again put it back to say 60. Okay, so now because we have so many rays and so many functions, FOV function available, so turning we can reduce to 1 degree. So now let's test it. We have set the FOV to 60 and repeat by FOV. Let's see how it works. Let's press the green. Oh wow, that's great. See, can you see it? That's wonderful. It's like, wow, this is like anything. See, right? So you can see it. This is like, this is wonderful. So this is like shadow effect, right? So many things are there, right? So this is really wonderful. This project, when we click the green flag, so it is running, but can you see some issue? See, this is tilted to right as with respect to player. So how we can modify that? We can use spread of rays function, that is FOV, and we'll try to balance it. So how we'll do that? What we'll do, we'll just add a motion block, turn left block, we add it here, and then we'll add logical operator, divide by, and here we'll duplicate this FOV and put it here, and then we'll write here FOV divided by 2 degrees. So see now, let's see in full screen. Yes, it is now balanced. Both left and right beam is equally balanced. So we have done it. Now we want to go to 3D concept. For this purpose, what we will do, first of all, we want that this ray should be going from in x position minus 240 to plus 240, right? So let's to measure this point, because this is our line of sight. Okay, so to check the line of sight, we'll use x variable. So how we'll create that? We will go to variables, and so we will create a make a variable called x, and this is for this sprite only. And then what we'll do, and then we will do this here we'll enter set variable x to minus 240. Okay, so we have set it to minus 240. After that, what we will do, we'll add here a checkpoint, the change x. Okay, so we'll add it here. So how much we want to change it? Total is minus 240 to plus 240, 480. So we want to cover it with this beam. So with this beam is wide as FOV. So what we will do, we'll add a operator here, divide by operator, and here we will write 480, and then again what we will write, we'll go to our variables, divide by our FOV. So right, so now this is our total scene is covered. Okay, so with this 480. Okay, so we have created a 2D scene. We want to create a 3D scene. How we'll be able to create 3D scene from here? See, we have here, we can calculate the distance. How we can calculate? So we have a raycaster, and this raycaster, see this raycaster, okay, whenever it is there is object, so this distance we can calculate from raycaster to this player. Okay, and if we want to create a wall in a 3D view, how we can calculate? See, more the distance, okay, the height of wall is less. So we will use this concept and try to create a 3D impression. So first of all, we'll break this script and remove these pen down and pen up scripts, and here we'll create two variables. Okay, so variable will be, one will be our distance and other will be our height. Okay, so I have created two new variables, distance and height. Okay, I think we can create it once again. First we will remove this distance variable and then recreate it. Rename. Okay, this is cancel. Okay, so delete distance variable and we'll delete this height variable. Now we'll create these variables. Distance, this is for this sprite only, and one will create height variable for this sprite only. Okay, so distance, now what will we do? We'll first of all set distance to 0, and where we will place it? First of all, we'll join this here and then set distance will drag here, and distance will be our in sensing. So what will be distance to the player? We have already discussed. So this distance will be set to the distance to player. Similarly for height, as we have discussed, so we'll again go to this variable and set height. So we'll height, so height will set to, we'll use logical operator, division logical operator here, and we'll say a random number, say for example 4000. Okay, so divided by this beam, or say, so how we'll be able to calculate? So this beam distance is calculated by this from raycaster to player. So more the distance, less is the height. So okay, we'll divide this 4000 by FOV. So FOV is our variable, so we'll use the FOV here, divide by FOV. Okay, so this is done. Now what next we want to do? So before we add this pen up and pen down, first of all we'll go for x and y. So what will be x? X is our normal x. Okay, so we have already created this x here. Okay, so we'll go to x, and for y what we'll do? For y we will simply, for y we will go to height. So we'll go to in motion, we'll go to x and y, we'll drag it here, and for x we'll go to variable x, we'll drag it here, and for y we'll go to height. Okay, so next we are going to create pen down. Okay, so we'll create a pen down here. So this is our pen down. So okay, so next what we want to do? So we want to change y also. This now, see, some pattern has started building up. So for y, we'll here set y, we will go to set y, go to motion, so we'll drag this set y to, and what will we write here? Set y to, we'll write, see, 0 minus height. So height we have already calculated. So 0 minus height means this will be calculating its y position with respect to ground. Okay, so we'll use a logical operator here and draw here, drag here, and at 0 minus, we'll go again 0 minus height. Okay, so after this we'll drag pen up. So yes, here see, we were to divide 4000 by distance, so we have divided by FOV, so we will divide it by distance. See, now it seems working. So yes, see our this sprite. So we are able to see 3D shapes. Okay, so our first 3D prototype is working. So this is like wonderful, right? So we were able to change the variables here. Okay, that's great. That is great. So we are able to scroll it. Our sprite, this design is also visible. Okay, so for to make that hide this, what we will do, we will go to design, and here we will write, we'll go to go to the looks, and the looks will drag it down and find. So this set color effect. In color we will choose ghost effect, and we'll write it as 100. Okay, so we'll write it as 100 when the green flag is clicked. So further we'll hide this so many x distance, so we'll hide it. Only will FO will remain here. Okay, so now we'll set this ghost effect. So let us see how it works out. Yes, see, our project is now, that is looking beautiful. Yes, this is really amazing. So we have improved it a lot. So it is like I am able to move. That's great. So we are able to scroll through it also. So this is really good. This ghost effect. We have created a almost 3D impression. The lines are, there is a long space between these lines. So even if we increase the field of view by more, so our scene gets distorted. So we don't want to distort our 3D scene. Okay, so what we will be do, we'll use the resolution. So resolution means this one single ray will be more wide. Okay, so how we can do that? We'll create a variable, make a variable here, and let us name it for resolution RES and for all sprites, and press here OK. So here also we'll make it as a slider, and further we'll specify the range from minimum value will be 4 and maximum will be 16. Okay, so it is done. So resolution. So now what we are going to do next, this resolution variable is created, where we are going to add this resolution variable. Okay, so first of all we are going to see, we have created a FOV variable, right? So FOV variable we have created, so we have set it FOV as 60. So similarly we'll set our this instead of distance we will use this variable res. Okay, so we'll drag this, set the res. What will we set the res to? Say we initially we set the res to 8. Okay, so further what we want, we'll drag connect these blocks, and so now we have to be very particular. See, the pen size what we are using is, okay, so what is the pen size? So can we tell this? Yes, this is pen size 4. So instead of 4 which we are using here, we will now choose this resolution, right? So it will change it according to our requirement. So we'll just drag this res variable here. See, so resolution is 0, then it is like this. Yes, now see, are you able to see it? Yes, now our scene is also not distorted, and we'll just see here, right? Okay, so now I am able to see it, right? So that is great. So we'll able to see it, right? So we are able to scroll through it. That's great. Okay, so this we have done by using the res operator. When we reduce this res, these lines again become spaced. So we do not want this also to happen. So what we can do is we can check our script. So see here, raycast module, right? So this raycast is still working on based on FOV only. Okay, so but it should work on what basis? It should work on res basis. So how we will change this to from FOV to res? We will just turn here, instead of FOV, this FOV divided by 2, then we will, to calculate this, that it should correspond to, instead of FOV to res, we will create one more variable. So name of the variable, we can keep it scan lines. Okay, for this sprite only. Okay, so then scan lines, this is there. So scan lines, what we will going to do with the scan lines? So scan lines, we will just first of all set scan lines. Okay, set scan lines, we will just drag here scan lines and drag this, set the scan lines to here, and where what we want to set here, we want to correspond to resolution. So resolution, so what is our total spectrum? This is 480 pixels. So we'll just write it here, resolution this operator, division operator. So it will be 480 divided by res. So what is the variable res? Is our resolution variable. Okay, so this is done. What else we want to do? Okay, so we want to, in this single ray also, we are turning it by 1 degree, but now it should correspond to our FOV and scan lines. Okay, so this and this also should, instead of this FOV and 480, it should correspond to our resolution. So we'll change x by res and turn this 1 degree, instead of 1 degree, we'll turn it by resolution divided by scan lines. So we'll drag this operator here, and here also again go to the variables. So where is res is there. So we will write resolution divided by, so resolution is done. So we want FOV divided by scan lines. So FOV divided by, this is the operator is hidden. Okay, stop this script, and then we will drag this out. So what we want this should move by FOV divided by scan lines. Okay, FOV first, FOV, now we want to drag it here. So now it will turn based on our field of view and scan lines. So let's test how it works, right? Okay, so let's click the green flag. Yes, see now, see, although it is, but it is still sticking to it, right? So this is very good thing. It's not getting spaced out as it was doing earlier. So we are able to do it, right? So we can, for the safety, we'll write it as just 8, and now see, we are able to move it, and this is not scattering out, right? So we are still, we are going to want to upgrade it. Okay, so this is like wonderful. When we this move the slider, okay, whenever it is at odd position, see, there is still a little bit confusion is coming, right? So how we can we change it? So what is the best way to upgrade it? Okay, so let's first fix it at 8. Go back here. So here we have set x to minus 240. So instead of setting x to minus 240, we'll just basically shift this by depending upon the resolution operator. So we'll, instead of here we'll write a operator. So we'll write here minus operator here. So here we'll write, so res divided by 2. Okay, so res divided by 2. So this is like not working properly. Okay, so res divided by 2. Okay, so this is working, right? So it's still, we'll drag it out. So first of all, what we want res divided by 2. First negative operator is there, and left side we want a this operator. Okay, so this where we'll write variable is res, then divided by, gets scattered, right? Once again I have to be, okay, so resolution, okay, so we res divided by 2 minus 240. Okay, so this we have done it. So let's now see if this problem gets resolved. So let's run this project. So now see if, yes, now problem is resolved, it's not getting scattered. Okay, so we are able to see it, right? So this is a good thing. Okay, so this resolution now for all odd and even, it is working. Okay, so let's now, it's good, this feels good, right? Okay, so we are able to move it. Okay, so this is good. So now as we travel further, or as the distance is more from this player, the scene should appear little more dark. Okay, this wall. So what we can do, we'll just add a set pen color block here. Okay, so in the single ray cast, we'll set pen color here in between. Here we will add it, and what will be the color? Instead of color, we want brightness to change. Okay, so we have selected the brightness. So brightness, what we want, brightness should be between, dependent upon distance. So what we'll do, we'll subtract it from, say for example 120, and the distance divided by 1.5. Okay, so we'll first of all, where we go, we'll go to logical operator and get minus operator here, and here we'll add a variable distance. Okay, so distance minus, so what we want that should be, distance should be here, so distance divided by, so here, if then we have to find one more logical operator, divide by here. So here we'll write distance, okay, so we have to little subtract it here, so drag it here, and distance we have to here, and distance divided by 1.5, and further this whole should be subtracted from 120. Okay, so this is done. Now let's see if it works. Yes, see, the more the distance, the less bright it is. There is now depth. Okay, see, It's now 3D. I am really enjoying it now. This color, this brightness is increasing as we are near, and brightness is less as the wall is far away. Now height is less, and as well as the color brightness is less as we move further from player. Okay. If we see, the height of wall at center is more. Okay. So this effect, when we move the player, this effect is due to what? Because we have taken distance of player to the wall, right? So due to this, we sometimes, this is what happens, it is calculating the distance based on this factor. So how we can correct it? For this purpose, we will just put a different, set the distance to here, and set the distance where we will set to here. We will just place the distance multiplied by cosine of direction. Okay, so distance is our, and then we'll put a logical operator here, multiplication logical operator. So first of all, we have to put here as distance. So we'll go and find distance. Okay, distance is there. So our is the variable. Okay, so this is our distance. Okay, this is distance. So distance, now distance should be multiplied by cosine of angle. So we will go to logical operator. There is cosine of multiplied by cosine of direction. So now direction is, what is our direction? One is initial direction and one is our this normal direction. So we'll first go to this direction and use logical operator also, my negative logical operator, to put it here. And first now we'll go to normal direction. So now this direction is relative. So we want that this direction should be compared with the initial direction. So in initial direction, how will we measure? Just we will create one more variable and name the variable as dir and make for this sprite only and click on OK. Okay, so this direction is there. So, and now what we are going to do, we'll define raycast. We will just set this dir. So we'll set this dir initial to initial direction. Okay, so we have set it. So when it changes, so we can now find out the change between both of them. For that purpose, we will just write it as direction minus dir. Okay, I think this looks good, right? So now let's test this code by first joining these blocks. Yes. Now see, are you able to see the straight lines? So even though I move forward or reverse, the lines are straight. Wonderful. So we are able to write. So all the lines are now straight. So we have created a effect where now the lines are straight using trigonometric function from math. Can we tell what can we else do here? So see, the color is dark black. So we can change this depth of color here also. So how we can do that? We can go to the costume. Okay, so let's go to the costume. and can hide these scan lines. Now go to the costume for backdrop. Backdrop, go to the backdrop and just we'll click paint a backdrop, right? Paint a backdrop. We'll just select this color and we'll select the color as say brightness 0, and this we can go for 100. Okay, so and this outline is not required. Okay, so now we will just after this we will go to gradient. So gradient we will select here as a gradient. So gradient, so first is dark, then we will go to gray. Say 0060. Second we will select this. Okay, after this we will just draw this. Okay, looks good. So now I will just Control C and Control V. I will just drag this second block here, keeping it like here. So after this I will just press flip vertical. Yes, that's look really great. So let's see here. Yes, see that's really wonderful, right? So you're able to see more depth here, right? So that's really wonderful. That's great. That's really wonderful. That's great. See, player is still visible, Raycaster is still also visible, and this we can remove this backdrop also. This we have removed it, and now we'll go here. So these player and Raycaster, how we can remove that? So for that purpose we'll go back to the code and in the code we'll go to press code and first we will go to player. In player, when green flag is clicked, we will just go to looks, and looks will choose the set color effect. Here we'll select this color effect and place it here, and instead of color we'll choose ghost effect. So we'll put it like ghost effect 100, and similarly we'll go to the Raycaster and again select color effect to 0 when the green flag is clicked. So here again we'll select the ghost effect and here we'll write ghost effect to 100. So thing is done. Let's now test it. Yes, now it looks really amazing. And yes, like wonderful. That is really amazing. That's great. Really great. That's great. So now the player is not visible, but I am able to scroll through. So this is really enjoying it. I'm really enjoying it. Okay. So as we are progressing, our game is now appearing more and more realistic. These walls, they have all these walls, right? There is no corners are not visible. So what if this color of this horizontal and vertical, like this wall and x direction and y direction, these walls, if you different color, can we do it? So let's check it, how if possible, right? How can we use different colors? Okay, so for that purpose what we can do is go to the design, and in design we'll go to the costume, and in costume, so before that Going to costume, we will just duplicate the design and name the design as design color. Okay, so design color. So now we will go to its costume of design color. Okay, in the costume we'll just click here and duplicate it. So after this we'll just select it by Control A. So everything is selected. Okay, so now I will just right arrow, I will press right arrow just once, so that this whole palette, this whole design moves just one pixel to the right, one step to the right. I will press arrow key, right arrow key once. Just see. Yes, I have done it. So now I will copy it. Control C. And after this, I can delete this costume 2 and go to the costume 1. Again, I will select it. Control A. And this time I will press left arrow key once. So it will move, whole design will move one step to the left. Yes, I have done it. And now I will paste my earlier copied on clipboard. So if we just want to see it, what has happened now, see, there are now right and left this. Okay, are you able to see? So there are now color, this color design color has overlapped it. So now let's see how to use it. We'll go to the code, and now in this code we'll again go to the Raycaster. In Raycaster, what we will do, in the Raycaster we will be going to create a if loop. If loop where will we add if loop. So this move we are moving one step. Okay, so we'll just disconnect it, and here we will use if and then and else loop. Okay, if then else loop is here. Okay, we'll connect it if then else loop. So what we are going, when then we'll connect back it. So what we are going to check in if then else loop. So first we will check that if it is touching the this design. Okay, so if it is go to sensing, in mouse pointer, this is design color. Okay, this second sprite. So if it is touching, then what we want that if it is touching, then what should happen? So we'll set the pen color, different pen color. So pen, go to pen extension. So we want set pen color to what we want. We say, for example, it is 58. And if it not, then set pen color to say 50. So else we'll say pen color to say 53. Okay, so it is done. So are we ready to test it now? Okay, hold your breath. Oh yes, see, that is wonderful, wonderful, wonderful. Yes, yes, yes. Now the corners are visible. So I am able to differentiate the corners. That's really great. Hope you enjoyed this video. So you can create some 3D maze from a 2D design. So further we can, if you want, you can upgrade. How you can upgrade? You can change the texture of walls. What else you can do? You can add different sprites which come when you pass through the path. So there are multiple things which you can do. Change the color of different texture. You can choose multiple textures, right? So hope it was a good experience. If you liked it, please subscribe to this channel. Thank you very, very much.